Yeah, perfect. So, yes. And she says because of the corresponding angle converse. Remember, you're proving two lines are parallel, so you need to use the converse. Let me just check to make sure you are correct. So in order for that to be correct, I don't know why I'm highlighting the exact same lines, because I really didn't do much. But if you turn it sideways, you can definitely see that those are corresponding angles. 62 and 62 are both top left. They're corresponding. Both of them aren't in the interior. They're both equal, so it is going to be your corresponding angle converse somehow.
You don't have to put postulate?
You do not have to put postulate. If you put it, that's probably a better answer. But at this stage of the game, I'm okay if you just realize it's the converse, honestly. I'm just looking for you recognize it's the converse because you're proving two lines are parallel. That is your big term here is the converse. All right, questions on that? Okay, so we're going to plow through the lesson because it's not that long. That way you have plenty of time to answer. I can answer questions on the homework, so I'll get to that right after I do the lesson. All right, this lesson is basically, we're stepping away from proofs in this lesson, and we're just going to use what we know about them. That we can now put numbers to stuff and say, well, hey, if I have corresponding angles being congruent, I have two parallel lines. If I have alternate interior angles congruent, I have two parallel lines. And if I have same side interior angles adding to 180, I also have parallel lines. So you're looking for all three of these and basically this entire lesson and homework. So it says state which segments, if any. So in the homework, there's going to be some where it's not parallel. So be aware of that. State the postulate or theorem that justifies your answer. So I need to decide if any of these lines are parallel. Bless you. Now, here's the thing. Krupa, I'll call on you in just a second, but here's the thing. Obviously, if two lines just look parallel, it doesn't mean they're parallel. But they're good spots to start off looking. They're good spots. Look for ones that look like they're parallel and see if you can prove they're parallel. It's a good way to start off. All right, Krupa. Yeah.
OX and IZ.
OX and IZ will actually be the parallel lines. Perfect. That will be the answer. And I'm going to work through kind of a thought process. So maybe the first couple parallel lines that you think might work are these two. Well, in order for those two to be parallel, 52 would have to equal 50, and I don't think they do. So those two aren't going to work. So the next parallel lines I'd look at are OX and IZ, which we already know are parallel. Let's just confirm why they're parallel. Well, in order for both of these to be parallel, this whole angle has to be equal to that whole angle. Well, 50 plus 30 degrees is 80 degrees. 52 plus 28 is also 80 degrees. They are corresponding angles, so it would be OX is parallel to IZ. And it'd be that corresponding angles converse once again. All right, our next one. Once again, do you have the answer?
No, I have a question.
Oh, yeah.
Wait, can you explain why O and W and I and Y aren't congruent? They're not congruent.
Why they're not parallel?
Yeah.
Because if you look at OW, maybe I'll draw it again. Let me draw it again. So we're like, these look like they're parallel, right? OW. Those look like they're parallel. Well, let's just make this stuff disappear really quick so you can look at it. These are corresponding angles, right?
Yeah.
Because this is top right, this is top right. In order for them to be parallel, these have to be the exact same angle. Are they congruent? No, one's 50 and one's 52, so they can't be parallel.
Oh.
If this one was 52,
Yeah.
then they'd be parallel,
All right.
because they'd both be 52. But because they're different measures. Yeah.
How come the OX line doesn't matter? Like that angle. How come that doesn't matter?
Because we're just looking at these two lines.
But then how come for OX and IZ they both both of the angles matter?
Because to get this full angle is both those angles added together.
Right,
Yeah. So in this case, I'm going to have a harder time doing it. But in this case, you need to really think about this line disappearing.
Alright.
That you're not focusing on that line. You're just looking at that 50 and the 30. Same thing here, that this disappears. And you're left with the 52 and the 28. All right, so when you highlight a line, everything else disappears. And you need to get that full angle. Does that make more sense?
Yeah.
Okay, good. Yeah. All right, on this next one, what I'd look at is maybe LA and TS are parallel. So we can look at a couple different transversals. We could look at that transversal. Yeah, sorry.
I was having an idea.
Okay.
Well, like 46 plus 44 is 90.
Mm-hmm.
And so then it's kind of like the same side interior converse.
And they have to add up to 180, right?
Yeah.
Yep. I'll get there. We'll get there. But I'm just going to look at these alternate interior angles really quick. This is 46. Do we know this measure here?
Yeah.
We don't. We do know this?
Oh,
No, we don't.
well, kind of.
We don't kind of even know it.
No, yeah, but we know it because we're on that same side, so the same side of the angle.
Do we have two parallel lines yet? Yeah. We do know it.
Yeah, because that forms a triangle. And then
Or we can't use that yet. We can use that tomorrow when we start learning triangles. All right, we're just looking at what we know in parallel lines. So we actually don't know that value. And I'm saying don't overthink this stuff. We can figure it out, but right now we're not going to, okay? So we're assuming we don't know that yet. All we know is 46 and that isn't. So that one doesn't do anything. But this one, EJ was saying, if you add these two things together to get that full angle, that is 90 degrees. And if we look at this 90 degrees and this 90 degrees, they equal 180. And they're same side interior angles. So LA would be parallel to TS because of same side interior angles converse. All right, we want to do one check real quick. So we know LA is parallel to TS. We also want to quickly see is LT parallel to AS. In that case, alternate interior angles need to be congruent. Are alternate interior angles congruent?
No.
No.
But it's the 90.
44 and 46 are alternate interior angles.
So we're not gonna even try to solve for like the T angle LTS.
Nope. Because if any pair of alternate interior angles aren't congruent, they're not parallel automatically. You don't have to check any further.
Oh.
So the fact that this is 44 and that's 46 automatically excludes these as being possible. They have to be congruent in order for them to be parallel.
Okay.
You don't have to check any further. As soon as you know for a fact they're not parallel, you don't have to check any further.
All right.
The whole reason why we had to keep checking for the other one, let's go back, is because this was a blank space. If this would have been 46 and this was 47, we wouldn't have had to do the second check. It wouldn't have worked either. All right? But because it was blank, I had to do the second transfers. All right, number 3. Number 3, yeah.
How do we figure out that LA and TS were parallel?
Because we came up with this angle here equaling 90, and this angle here equaled 90. So if you look at those two different angles, this angle and that angle, those are definitely same side interior, right? And if same side interior angles add to 180 or are supplementary, then they are parallel. We have that same side interior angles converse that says that. That if your interior angles same side interior angles are supplementary, then your lines have to be parallel. Okay? All right, number 3. Who wants to give me the parallel lines on this one? Who wants to give me the... Alicia. GA is parallel to EM. You positive? Why? How are you so positive? Because of the alternate interior angles converse. Do you mind if I check your work? No. Oh, okay. All right, so you're saying GA is parallel to EM, right? Which means this could be a transversal. So you're telling me that 48 is equal to 48? Oh, okay, then you're right. Our alternate interior angles are congruent, so they have to be parallel. All right, questions on these? Okay, so this is the ones that they just give you some numbers, and they ask you what ones are possible. In our next couple of examples, we're going to use the information they give us, which will guide us towards which lines are possibly parallel, and we'll see if we can actually prove that they're parallel based upon that. So our first one says measure of angle 1 equals measure of angle 8. So what I always like to do, especially when I just have a small one like this, I'm going to color in angle 1, and then I'll go ahead and color in angle 8. Well, based on those two angles, I'm looking at AR and PL being our possible parallel lines. They gave me angle 1 and angle 8 are congruent. Can someone tell me if PL and AR are congruent? And if so, how do we know for sure? Davian? They are? Alternate interior angles. Perfect. So we'd say something like PL is parallel to AR because of the alternate interior angles converse. I know it's a mouthful, and a lot of times it's just easier to put what theorem it is. But like I said, I don't like digging through that packet every single time. I like to just put alternate interior angles converse. Our next one's a little harder. It's a little harder because if I color in my angle 5, so let's color in our angle 5. And let's go ahead and color in our angle 3. Boom. Which one of those lines I just drew look parallel? Yeah. No, I'm going to make you guys do that. Just because I already had this slide up here. This makes it easier. I'm on number 6. Does PL, LR, or RP, do any of those look like they're parallel? It actually makes a triangle. When it becomes that difficult to look for things, you're going to know there's nothing parallel. There's nothing parallel. No parallel segments based upon the information. That's not saying nothing can be parallel. It's just saying on the information they gave us, I can't confirm anything. So I'm going to put something like no such segment. Yep. Just no, I will not do that one. Just give me like a paragraph. Sorry, Mr. Papian, I refuse to do this on the grounds that you did not give me enough information to determine whether two segments are parallel or not. In fact, you gave me a triangle, which does not help me whatsoever. Period. That'll work too. Okay. 5 and 7, you're going to do number 5 and 7. Labib.
Can you explain again why 6 isn't? That was such a segment.
Why 6 isn't a segment? Well, 6 is an angle.
Or no, I mean like number 6. How like the answer?
Is no. Look at those two things.
3 and 5.
3 and 5. Are there any parallel lines? Look up here. I drew this. We could easily say that AR and PL would possibly be.
Yeah.
But when I draw these two things, we don't even have two lines being connected by a transversal. We don't even have alternate. These are not alternate interior angles. These are not corresponding angles. These are not same side interior angles. So they're none of the they're not even the possible angles it could be. Plus, Labib, it's a triangle. Can any of those be parallel if I draw a triangle? No. All right, you are in charge of 5 and 7. Once again, tell me what lines are parallel and what theorem or postulate gives you. Are you giving me an answer or you have a question? Oh, yeah, go ahead. Hurry up, because we're going over these in 1 minute. Sangha. All right, what's the answer to number 5?
I got L, R, and PA.
Oh.
Right.
LR, I don't know, we'll go through it. Is parallel to PA, and why do you think that's true? What theorem or postulate?
Ultimate interior angle converse.
Yep, converse. Okay, let's see if that's correct. So they gave me angle 2. Angle 2 is that guy. Then they gave me angle 7. Let's do blue. Angle 7 is that guy. So we're checking basically, is PA congruent to LR? So it looks like those numbers are right. They gave me angle 7. They gave me angle 2, which are definitely alternate interior angles. Perfect. All right, who's got the answer to number 7? Who's got the... So I'm coloring in. You're making me color it in?
Yes.
All right. APL. Okay. And do the same thing for PAR. Okay.
And then you'd be looking at PL and AR.
So I'm looking at PL and AR. So I'm looking at that line and that line. I'm just trying to see if they're parallel, right?
And those two angles add up to 180 degrees.
So we're looking at that angle and that angle equaling 180 degrees. Why is that important?
Because that's their same side interior.
They're same side interior angles. And we have a theorem that says, hey, if your same side interior angles are supplementary or add to 180, then they're parallel. So they're good, right? Awesome. So we're going to say that PL is parallel to AR, and that is going to be because of our same side interior angles converse. You have to say it like that, by the way.
Okay.
You have to. Otherwise, you lose points.
I will try.
Okay.
Not right now.
All right. You got to practice first.
Yeah.
Okay. One more problem. One more problem. We're going to find values of x and y that make two different pairs of parallel lines. So the first pair I need to make is AC is parallel to DF. Then I need to make sure that AE is parallel to BF. To do that, we're going to tackle these at one parallel line at a time. So we're looking at AC and DF.
Which one we want to do?
And if you look at BF, no, I want to do this one first. If we look at that BF,
Oh yeah, right. Yeah.
that would make 3x plus 20 and x plus 50 alternate interior angles. Those are alternate interior angles of these two lines. In order for AC and DF to be parallel, alternate interior angles must be congruent. So that means this angle and this angle must be congruent. So we're going to set up an equation that makes them congruent. So we're going to go 3x plus 20 equals x plus 50. All right, we're going to get all of our x's on one side, all of our numbers on the other side. So first thing I'll do is I'll subtract 20 from both sides. Bloop, 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 bloop. And we'll have 3x equals x plus 30. Subtract x from both sides, minus x, minus x. And we'll have 2x equals 30. Divide by 2 and we have x equals 15. Cool. Cool. So if my x is 15, if I plug 15 in here, I have 15 plus 50, which equals 65. So maybe I'll do that. Maybe I'll quickly talk about that. So if I plug that in for our x's, that would make this one equal to 65 degrees. And 3 times 15 is 30 plus 15 is 45 plus 20 equals 65 degrees. 65 is equal to 65. I'm good so far. I made DF and AB parallel based upon that x value. Now we're going to shift to the other line. The other lines are my AE and my BF need to be parallel. So that means that this line down here, that DF is our transversal. What do these two angles look like based upon that green drawing? What kind of angles are they? You're thinking alternate interior, same side interior, or you're thinking corresponding, or you're thinking corresponding. Random, no, I don't think I ever.
Same side interior.
They're same side interior, and what does same side interior have to add up to? 180. So we just need this angle here to add up to 180 degrees. So what is the measure of that angle?
For number 2, for step 3, I put, so it's the angle CDE is congruent to angle BEA, and I put definition of congruent instead of substitution problem.
There's no such thing as definition of congruence,
Well,
I guess.
if they're the same.
Oh, I see what you meant. I see what you mean. Yeah, I'd be okay with that.
Okay.
I'd be okay with that because it's such a simple thing because they're both equal to 90 degrees. It's such a hard little thing. I'd be 100% okay with that. Yeah. Oh, let's go left to right, Krupa. I can. I hope so. Otherwise, I'm a terrible, terrible teacher. All right. So we have our givens, right? So we have angle C is congruent to angle 3. And we also have BE is perpendicular to DA. Da, da, da. All right. So I have C is equal to 3. So it's always a good idea to kind of look at those angles. So I'm looking at that angle is equal to that angle. And then I'm looking at BE is perpendicular to DA. All right, so BE is perpendicular, so that means that this is a right angle. That's a right angle. So I got all that just from the given. Okay with that? All right. I need to prove that CD and DA are perpendicular. So I need to show that this angle here is 90 degrees. That's what means it's perpendicular. Well, if that one's 90 degrees, so if we look at this DEA is 90 degrees, if I just prove that these two lines are parallel, then I could say by corresponding angles, these both would be 90 degrees. So I just need to prove these two are parallel, but look at these two. What kind of angles are those? Corresponding. So my first step I can jumping right to saying that those two lines are parallel. So I'm going to go ahead and say that my step 2 is CD is parallel to BE. I should put given over here. And that is strictly because angle C and angle 3 are congruent to each other and they're corresponding angles. So it'll be a corresponding angle converse. All right, my step 3 is now saying that, well, you know what? The measure of angle CDE is going to equal 90 degrees. And that really is because BEA is 90 degrees and their corresponding angle. So this will actually be our corresponding angle postulate. Or you could have also you also could have said BED is 90 and you could have used same side interior. You could have used either one of those. And then the last step saying they're perpendicular by definition of perpendicular, right? So there's one more step. All right. We're going this way. Yeah. Yeah. 2 is probably one of the harder ones. And so several of you might want to pay attention to this, especially if you have stuff wrong. So our first thing is our given. Our given is BE is perpendicular to DA. And CD is perpendicular also to DA. I need to show at the end of the day that 1 is congruent to 2. Well, if I'm looking at 1 and 2, do you see how they're alternate interior angles? Well, I need to just show that CD and BE are parallel, and then I can say alternate interior angles. So my whole goal right now is to prove that CD is parallel to BE. Well, we have two perpendicular things. Well, perpendicular lines tell you the definition, by definition of perpendicular, they create 90-degree angles. So I'm specifically looking at those two 90-degree angles that are created. So my first step was my given. My second step is going to be able to say that those two angles are actually 90 degrees. So I'm going to say measure of angle CDE equals 90 degrees. And I'm going to say the measure of angle BEA also equals 90 degrees. And that is the definition of perpendicular lines. That is, by definition, they equal 90 degrees. Are you okay so far? Well, I picked those two specifically because what kind of angles are they in reference to each other? They're corresponding angles. And we have that postulate that says if corresponding angles are congruent, then they must be parallel, right? So my next step would actually be to say that, well, I guess I should probably say that measure of angle CDE equals the measure of angle BEA. You don't necessarily need that step. It's just nice to flush things out. That is, I guess I would use substitution there. Then I would go ahead and say the lines are parallel. That CD is parallel to BE because corresponding angles are congruent. So we can use our corresponding angle converse. Now we have CD is parallel to BE, so we can jump straight to our final. Angle 1 is congruent to angle 2 because they are alternate interior angles now that we have parallel lines. Does that all make sense, Sophia? You sure? Okay, that's probably one of the harder ones that were on there because you got to flush a whole bunch of stuff out. All right, then we're going to the right. Did we have questions on the right side of the room, or was it answered? Did you have a question? It was already answered? Cool. It's always nice when that happens, right? Other questions? Now's the time to ask. Next Tuesday's our test. Next Tuesday's our test. Davian.
No, Mark, for the first portion, do you want us to name like why too?
Oh, yeah. On the homework for tonight, yeah. I don't know. Did I put in the directions? No. So technically you wouldn't have to, but it's good practice, right? Other questions? So on my answer guide, I probably didn't put it down then if I didn't ask for it, but it's good practice. Yeah, we do have a test next Tuesday. It's on the board and it's on your chapter sheet. Okay, if there's no question for me, then the rest of the time is yours.